This is the video for Complete Problems 1 in the Gas Laws unit. My first example problem says, a cylinder with an adjustable lid contains 1.30 liters of gas at 3.88 atm. The volume is changed to 6.40 liters. Temperature remains constant. What is the final pressure of the gas? So I have my givens, 1.3 liters, 3.88 atm, and 6.4 liters. And I'm looking for the final pressure. Liters tells me that's volume. That's the initial condition. So V1 equals 1.30 liters. ATM tells me that next value is pressure. That's the initial condition. So P1 equals 3.88 atm. Next, I have 6.4 liters. That's a new condition, so that's V2 equals 6.40 liters. And I'm looking for pressure, so P2 is unknown. So now I need to pick an equation that has these variables in it. I'm going to pick Boyle's law. P1 V1 equals P2 V2. Make sure to pick an equation that matches what you have and what you're looking for. So for P1, I'm going to plug in 3.88, V1, 1.30 liters, equal sign. P2 is unknown, so we leave it as P2 in the equation, times 6.40. First, I'm going to multiply 3.88 times 1.3. I'll punch that in my calculator. And you get 5.044. So to solve for P2, we keep this equation, we write equals P2 times 6.40. Now we want to get P2 by itself. Right now we're multiplying by 6.4. So to get rid of 6.4 and to get P2 by itself, we're going to divide both sides by 6.4. On the right side, 6.4 cancels. So you can punch in your calculator 5.044 divided by 6.4 equals, and that gives you P2, and that's equal to 0.788. This is pressure, and the unit for pressure in this problem is atmosphere. The next problem I'll do says recommended tire pressure for your car is 2.31 atm. You fill your tires on a day when the temperature is 27.1 degrees Celsius. The next day, the temperature drops to negative 8.10 degrees Celsius. Assume the tire volume remains the same. What is the tire pressure after the temperature drop? So you've gone out on a day where it's warm, it's 27 degrees Celsius, you fill your tires up to the recommended amount, that's 2.31 atm. And that's the temperature. Then the temperature drops, it gets really cold the next day, and we're down to negative 8.10 degrees Celsius. And we're going to find that new pressure. Okay, so ATM tells me that's pressure. That's the initial condition, so pressure 1 equals 2.31 atmosphere. Temperature 1 is 27.1 degrees Celsius. And then when that temperature changes, that's T2, that's equal to negative 8.1 degrees Celsius. And I'm looking for the new pressure, or P2. So there's something I have to do before I can pick an equation. I see degrees Celsius here. I can't use degrees Celsius in my equation, so I need to convert this to Kelvin. I'm going to add 273 to both of these temperatures. That will convert my temperature from Celsius to Kelvin. For the first temperature, I get 300.1 Kelvin. And for the second temperature, make sure to remember that that's a negative 8.10. I get 264.9 Kelvin. Now I can use those temperature values in an equation. So I need to pick an equation that matches these variables. So I'm going to pick P1 over T1 equals P2 over T2. I'll plug in 2.31 divided by 300.1. Make sure to use the Kelvin value. Equals P2 divided by 264.9 for T2. There are several ways to isolate P2 algebraically. You could cross multiply. I like to divide 2.31 divided by 300.1 and then go from there. If you do that, make sure to write several digits after the decimal. So 0.007697 is what I get, equals P2 divided by 264.9. Now I want to get P2 by itself. Right now I'm dividing by 264.9, so I'm going to multiply by that to get rid of it. I multiply both sides by 264.9. It cancels on the right side. So P2 is equal to, and I'm going to plug in my calculator, 264.9 times 0.007697. And that gives me 2.04